Now on Friday we talked about how we can factor certain perfect square trinomials down into one parenthesis squared because their two parentheses were identical. And on Friday, it just happened that all of our problems ended up where you were already starting with a perfect square trinomial. But sometimes the problem doesn't start out like that. And you need to kind of force it to turn into one of these perfect square trinomials. And we call this completing the square. Now there are several steps. One thing to notice is step 4 and 5 is basically what you did yesterday. So the only new steps is really we're adding steps 1, 2, and 3, okay? And we're going to work through this with example number 2. We're going to skip number 1. So example number 2 is x squared plus 10x plus 8 equals 0. Well, right away I noticed that 8 is not a perfect square. So this is not one of those perfect square trinomials as it's written. So I'm going to go through this method. Step 1 says if a is not equal to 1, divide both sides of the equation by a. Okay? Well, in my case, my a is a 1, so I don't need to do that step. Step 2 says rewrite the equation so the constant term is alone on one side of the equality symbol. Basically what that means is they want you to move c to the other side. They want your problem to look like this to start. And so I'm going to do that, and I'm going to subtract 8. Because when we're completing the square, we are really only interested in working with these terms, okay? Now, step 3 says square half the coefficient of x. They're talking about your b value, so they want you to do b and cut it in half, and then square it. So for our problem, 10 divided by 2 is 5, and 5 squared gives you 25. And then it says add this to both sides of the equation. So I'm going to have x squared plus 10x plus 25 equals negative 8 plus 25. This is now a perfect square that I can factor using my pattern from Friday down to x plus 5 squared. And over here, negative 8 plus 25 is 17. And I am now ready to solve by square roots. Square root both sides, and you end up with x plus 5 equal to positive or negative square root of 17. And then to get x by itself, I would subtract 5. And so my final answer is negative 5 plus or minus the square root of 17. Now, if you look at example 3, this is one where we do need to do step 1. Notice we have an a value of 2. So the first thing you're going to do is you're going to go through and divide every single number in the problem by 2 to get rid of it. That number has no effect on our actual solution, so we may as well just get it out of the way. And now I'm going to go through the completing the square process with what's left over. The first thing I'm going to do after that is move c to the other side. So I did that by adding 7. Next, I will find b divided by 2 squared, which in this problem ends up being 4. And I'm going to add that to both sides of my problem. This is now a perfect square trinomial, which can be factored down to x plus 2 squared. Over here, I now have 11. And when I solve by square roots, you will end up with x plus 2 equal to positive or negative square root of 11. And so when I subtract 2, my final answer is negative 2 plus or minus the square root of 11.